Hello, good morning. Okay, Elias, display. Thank you.
So the last time we discussed about the discovery of the chemistry and how the concept of chemistry begins and uh, and which scientists have uh, played their important roles in the discovery of different ideas or phenomena. So today we will discuss about the lessons in chemistry and the next we will discuss about the basic chemistry. So what criterias or what general topics we have study in chemistry that the simple that is a general chemistry. So the first one is atomic chemistry that discuss with the study of atoms and the study of mole concept and the production. Basically, atomic chemistry deal with the uh, production of yield in the industrial level. And because we discussed the product structure at atomic structure, and just as in the concept of mole or their mass production. The next one is experimental techniques. This is also called as lab techniques. We will study the concept of crystallization, sublimation, and different techniques that are used in the production of different materials. So the next chapter is about gases, liquid and solid, and we will discuss the major concepts about the gases, liquids and solids. Next chapter is about the chemical bondings, and the chemical bondings includes this material as well. And basically the chemical bonding include the bonds that are between the gas molecules and liquid molecules and the solid molecules. So how many types of chemical bondings are and what they play important roles in the chemical and structural level of these gases, liquid and solid. So all these concepts of bonding that play an important role in the holding the structure of these molecules we will discuss in the chemical bonding. And next chapter is thermochemistry, and this name also mentioned as thermo. Thermo means temperature, and the chemistry as we study, and we say that chemistry is basically the study of structure and composition. So we will study what temperature play important role in the gases, liquid and solid structure and their composition, and how we can affect different molecule and structures by the temperature. So the next is chemical equilibrium that will study about the uh, effect of different reactant and product by the different materials or maybe with the catalyst. The next is about solutions, and solution chemistry discuss about the uh, types and the composition of materials, such as uh, if we have liquids and we mix two liquids such as alcohol and water, and what they uh, effect on each other. So same as if we take another example of solids with liquid and gas with liquid, and what effects they impact on each other, that will be studied in the chemistry of solutions. And also we will study the effect of elevation boiling in the boiling point, decrease in the freezing point, such as these concepts are discussed in the solutions, and such as Raoult's law. So electrochemistry discuss with the study of electrical charges, how electrical charge or ions are uh, have their effect on the conductivity of electricity, and which atoms or ions play important roles in the electrochemistry. So the next lesson is reaction kinetics. Reaction kinetics basically deal with the study of those product or reactants that are used in the are used at industrial levels, and these are maybe and their effect can be uh, excluded or consequence by the study of their rate of reaction. So basically reaction kinetics discuss with the rate of reactions, and we will discuss different law of scientists, how they affect the uh, industrial product of the different products, such as enzymatic reactions and uh, different laws. Next, this study from atomic to reaction kinetics called as general chemistry or simple chemistry. From inorganic chemistry that involve the study of periodic tables and their peculiarities of the top element from their member element, and the properties of and the reactions of different atoms in different conditions, that all discussed in the study of inorganic chemistry. And we will discuss the study of different products, such as reaction for sorry the uh, distillations of different material from the ore. So these all are discussed in the inorganic chemistry.
Get out from the class. Get out from the class, Danny. Get out.
Okay, Mom.
I don't want you to stay in the class, okay?
Okay, no problem.
No more class for you, okay?
Okay.
You have to listen to Khan Academy and another one, okay?
Bye, teacher. I have to leave.
Okay.
Have a good day.
Thank you.
Bye, Daniel. Thank you.
So the organic chemistry discuss about the IUPAC, that is basically a international name, and IUPAC is a simple abbreviations that discuss about the abbreviations of different chemical and how we can name the different compounds, such as that include carbon and hydrogen. And basically organic chemistry involves alcohols, ether, benzene, aldehyde, carboxylic acid, ketones, and major molecule that have play important role in the basic cell level, such as carbohydrates, etc., lipids, or proteins, etc. So these all are not a single terms. These all are separate chapters. Alcohols have different uh, chapters, and ether, benzene, and aldehyde, these all are single separate chapters that we will study at in the next class. At the next is environmental chemistry, or it also called as industrial chemistry. Environmental chemistry discuss with the problem and solutions of different materials that impact on the environment. And industrial chemistry discuss with the study of production of paper and different materials, such as coster and wood, and distillation of carbon from the different materials. So these all are the branches, or maybe called as chapters, that we have to study in this class. Sorry, not in this class, in the next classes. So these all are singles, the names of the chapters, and I have just discussed just brief about them. So now, what is the process of chemistry, or called as lab techniques or process of chemistry? Simply, process chemistry involves the development and optimization of production process for chemical compounds and the scaling up of laboratory reactions, particularly in a pharmaceutical sectors. So process of chemistry means what process are used in the lab techniques. There are different process, such as we use in the reaction kinetics and rate of reactions. These techniques, chemical equilibriums, solutions, as Routledge is used in the solutions for the elevation and decrease in the boiling point, and Hess's law is used in the thermochemistry for checking out the for checking the energetics of the different chemicals in the thermochemistry. So these are different process in the chemistry that can be used as techniques for the study of different chemical or compounds. So there are many different process that we will study in all these chapters separately. So process of chemistry basically is a developmental and optimization of different products or compounds in the laboratory, or particularly this used in the pharmaceutical or medicinal sector for the productions of different medicines. Now, what is basic chemistry? And chemistry depends on the simple matters such as matter, element, and other substance such as atom. Basic chemistry have some minor concepts such as matter and atoms. Basically, the basic chemistry involves always about the matter and the element. So what is matter? Matter is anything that occupies a space and have some masses. So everything that is around you is called as matter, and all the things that have mass and occupy space are called as matter. So all matter, living or maybe non-living, are made up of element. So what is element? Element are the substance that cannot be broken down to a simpler substance with the different properties. So elements are the substance that cannot be broken down, and their properties remain the same because they are made up of single or the same type of substance. If we break into different substance, smaller substance, subatomic particles, they will also contain the same element. We can consider the example of a building that are formed by the same type of bricks. So every bricks is called as can be called as an element. So elements are the substance that cannot be broken down into a simpler substance with the different properties. So element cannot have different properties because they are cannot be broken down into more simpler substance. Elements that make up Earth crust and its organisms include different elements. Basically, in the major element that form the element of Earth and the organic life, that are carbon, and this is their symbol of carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. These are the elements that make up to 95% of the living organism by weight. So all the matter in the universe are made up of from these major elements, include carbon, hydrogen, nitrogen, oxygen, and sulfur and phosphorus. Now the concept of atom is that atom, the smallest part of an element, that display the properties of element, and we can say that if we broken down the element into simple or sub particles, then we reach to the atom. So atom is the smallest particle of an element that display the properties of element. Atoms are made up of subatomic particles that are protons that are positively charged and neutrons that are uncharged and do not have any charge particle. They are neutrals, and electrons that are negatively charged particles. So here is an element, or we called it as an helium atom, that is basically made up of 2 protons and 2 neutrons. So these are the 2 electrons that are revolving around the circle, or this is the major part, is called as nucleus. So here are the sub properties of helium atom. Particle that proton contain charge +1, atomic mass 1, and the location is nucleus. So proton always be found in the nucleus. Neutron that contain electrical charge of neutral, and atomic mass always 1, and location is nucleus. So proton and neutron always found at the center of the atom, and they made up nucleus. And electrons that contain negative charge and have 0 mass always be found on the boundary or energy levels of the atoms. So atomics, what is atomic symbols? A representation of any element is called as atomic symbol, and how we represent by simple letter, as it may be used from the name of the element, such as carbon. We use C as a representative element, and the upper case represent the atomic mass, while the lower case represent atomic number. And this atomic mass basically is the sum of proton and neutron. Atomic mass, the number of is equal to the upper case is the number of proton plus number of neutron. So how we can find the mass of any element? We have to sum the number of proton and the number of neutron in any element to find out the atomic mass. The atomic number is always equal to the number of proton. This is the simple representations of periodic table, and in the next slide we will discuss the number of rows and the number of columns in the periodic tables. So these horizontal lines basically represent the periods, while these vertical columns represent the groups of the periodic tables. There are some isotopes that any element can have. So we not include isotopes in the periodic tables because there are not much spaces for every element at these places, because their mass always changes while their atomic number remains same, and that's why this periodic table is basically based on the atomic number, and these continue as in the sequence form. hydrogen have 1, helium have 2, lithium have 3, and beryllium have 4 atomic number. This sequence is in the proper way. So that's why we not places the isotopes in the periodic table. So what isotopes are basically, these are the atom of same element, but they have different atomic masses. So atom of the same element with a different number of neutron, that is another definition of the isotopes. Atoms of the same element with a different number of neutron, and we can say that an atom of same the element that have different mass number are also called as isotopes. What are the radiations are? As radioactive isotopes decay, energy is released in the form of subatomic particle or radiations. The radiation may be in the form of alpha radiation, beta radiation, gamma radiations, each with the different energy levels. Both, all of these are dangerous, but can be useful with the limited amount. So cobalt 60 irradiations for sterilization of the plastic, potassium 40, etc. There are different kind of radiations that are used in the medicinal at medicinal level for the cure or for the treatment of different disease. And these radiations basically evolve from the different kind of radioactive isotope or atom. So some use of low energy radiations can be used for the thyroid gland and maybe for the MIR. Some uses of high energy levels radiations are used at different levels. It can be used in the lenses. Or what electrons, the definition of electron. If an atom is electrically neutral, the number of proton positive charge is equal to the number of electron negative charge. So we can say that if because all the matter on the earth want stability, so we can say that if the number of positive charges are 10, then there will be definitely there will be the number of negative charge will be 10 for to neutralize the same 10 positive charges. So we can say that if an atom is electrically neutral, then the number of proton then equal to the number of electron. So every time you will see as the number of protons, if in an atom is 6, then that atom will have 6 electron around the nucleus. What energy levels? The electron shell. Basically, as we stay in our houses, the same way electron remain in the cell level. So the boundary or the area where the electron can be found is called as energy levels, and every electrons have different energy levels, and so their radiations or their energy level can be increase or decrease with their energy levels. So the first shell closest to the nucleus and can contain 2 electrons. Each additional shell can contain height 8 electrons. So basically energy levels are in the form of stairs. We can say that the base are closest to the floor, and that will have small energy, while the upper stair have more height. As we say in physics, as the height increases, the potential energy always increases. So as the number of shell increase in an atom, the number of electron also increases, and the energy of electron always increases according to the shell number. and there will be the different number of shell level in every atoms. Hydrogen have only one shell, helium has two, and lithium always have two shell around them. Each lower shell is filled with the electrons before the next higher level contain any electrons. So basically these concepts are for from the atomic chemistry and how we can place the different number of electrons in the different shells. We will study in details there in the atomic chemistry. So basically these are the shells, or we can say it as energy level, and this is the first energy level and the outer one is the second energy level. As the gap between first and second increases, the energy level of the electron always increases. So this electron that this contain three shells. This is the first, this is second, and this is the third. So this electron always contain more energy than the first shell, while the speed of electron of revolving will be the speed of electron will be more as they are closer to the nucleus, while if they are moving away from the nucleus, their speed of revolve will be less. And let's say that hydrogen has one electron. This is carbon that contains six. They contain six proton, and therefore there will be six electron in the carbon atom, two in the first shell, while four on the outer shell. Same as nitrogen that contains seven proton will have seven electrons in their shell. The first shell contain only two electron, while the second shall have ability to contain the 8 electrons. So that's contain 1, 2, 3, 4, 5. So basically we have just 5 electrons remain because 2 are filled in the first level. So 5 remains. Then they will be put into the second energy level of the nitrogen atom. Same as oxygen that have 8 number of proton will have 8 number of electron, and they will be in the form of as shown in the sun. So this is the phosphorus have 15 and will have 15 electron, and this is the sulfur and show as in the form of Bohr models. This is the periodic table, and horizontal lines always shows the periods, and in each periodic table there will be 7 periods and 8 columns. Every periodic table have 8 group, while 7 periodic periods, and these groups these groups are divided into the 2 forms. The one is called as A group, while the other is called as B group. So basically the atoms that have electron in their p orbitals are called as typical elements, while the element that have electrons in their D shells are called as non-typical elements, and these are the B type of element, also called as transition elements. So the area from beryllium, from indium to zinc are called as transition element, and this is not a complete periodic table. We will see in the next, then we can say. So electron atom can give up and accept and can share electron to have 8 electron in the outer shell. So if an atom wants stability, Okay. So if an atom wants stability, it can accept electron and it may share electron, or it can give electron to another atom to get a stability. And these electron that he want to share, or that want to give up, or that want to accept, will be from the outer shell of it element. So remember, the if an atom is gaining electron, the charge will it attain will be the negative. If an atom is losing electron, uh, then it will be form a positive ion, because the negative charge is decreasing from them, so they will have more proton and will be called as cations. While the sharing of electron only form a bond that will not form positive or negative ions, but they forms a partial positive charge that will be called as partial positive and partial negative charge, and they may be in the form of different bondings, that can be tight bonding, or that may be a loose bonding. So what molecules are? Molecules form when two or more atoms bond together, and we can say that molecules only form when a stable molecule is formed, because molecules that are formed with the two or more element or atoms only form when they have a stability in their structure, as oxygen contain two atoms of their own uh, types, so they will be remain as stable element, and they have no need of sharing electron, giving electron, and uh, losing electrons. So simple definition, simplest unit of compound. Other example, carbon dioxide, methane, water, and glucose. These all are molecules and can be found as independently, because they do not want to share their electrons, or they do not want to give up electron to other elements, because they have stability and they remain in the same structure. And the stability always came as in the form of balanced electron, and we say that the outermost shell have 8 electron. So by sharing electrons uh, in the bonding form, these two oxygen atoms, when form a double bond, they will have 8 electron in their outer shell. So molecule form when two or more atoms bond together, while the compound form when two or more different element bond together. Uh, Molecules and compound. Molecule form when two or more same type of atom are formed, while the compound form when two or more different element bond together, as H2O is a compound and molecule as well. So when a chemical reaction occur, uh, the energy may be given off or absorbed. So this is called as endothermic reaction or exothermic reaction. If a reaction is absorbing energy from the surrounding, that will be called as endothermic reaction. While if formation of a molecule or compound is releasing energy in the surrounding, that will be called as exothermic reaction. And chemical bonding that involves the formation of compound or molecules always be with the given off or absorption of energy, that are called as exothermic or endothermic reactions. Ionic bondings. Basically, ions are charged particles that are formed by the losing or gaining of electrons. So ions are charged particles that form when electrons are transferred from one atom to the another atoms. So atoms that gain or lose electrons are called as ions. So this is the definition of ions. Ions that are that form by gaining or losing of electron. So positive ions will be formed when an atom lose electron, while negative ions or anions form when an atom accept or gain electron from other atoms. Ions are charged particles that form when electrons are transferred from one atom to another, while ionic compound formed when uh, ionic compound are formed when an ionic bond formed between two ions. If we say sodium is an ion, that is Na plus, and calcium Cl negative, if they come close and they will form a bond that is called as ionic bond, that will be in the form of uh, electrical charge. So the bond that is present between the sodium and calcium, or chlorine, will be called as ionic bond, and that will be in between of oppositely charged ions, and the ions will be sodium and chlorine. So here is an example of ionic bonding. That is the sodium ion, and this is the chlorine. When sodium, this is the last electron that is in the last shell of the sodium, and here is chlorine that have 7 electron in the last shell. If this sodium wants stability, it have to lose this electron. So after losing this electron, it will have 8 electron in the outer shell. So this shell will be reduced or destroyed, and this uh, electron will be put into the orbits of the chlorine. After gaining electron, chlorine will have 8 electron in the last shell, and it will be stabilized. So after, as these both came close to each other, they form positive and negative bond between them, that is called as ionic bonding when they form ions. Next is the covalent bond. And in covalent bond, atoms share electrons, will not transfer electron from one element to other element. So basically covalent bonding is formed by the sharing of electrons, and they can be relatively from strong to they can be strong, and they may be in the form of loose bonding. The one of the example is hydrogen and HCl that have strongest bond between them. Covalent bond are shared pair of electrons, and each atom is acquiring a more stable outer electron configuration. As in the example here, this is the structure of H2 molecule that can be said as homoatomic covalent bond, that is between the two hydrogen atom, as both of these sharing electron. These two electrons are shared for this atom and also for this atom, so they will keep the electron, and will be in the form of H2 molecule. And same as this is a oxygen O2 molecule that will form a double bond between them, and here are the 4 electrons that are shared paired by the both of these. 2 are shared by this oxygen atom, and 2 are shared by these oxygen atom. So a double bond between of these oxygen atoms are formed, and they will form a covalent bonding. And always remember that a single bond is always stronger than the double bond, and a double bond is always stronger than the triple bond. So next are the shapes of molecules. These all are just a brief study of the bonding, while you have to study a complete chapters on these. In the chemical bonding, you will study ionic bonding, covalent bonding, and dative covalent bond, molecular bond. All these or will be studied in the detail structure with the examples in the chemical bondings. So same as for the shapes of molecule, and there are different theories about these the shapes of molecules, and we will study hybridization structure and different structures such as methane molecule, ethane molecule, and the structure of nitrogen, ammonia structure, and water structure. So the shape of molecules, and there are different studies about them, and we classified into AB3 structure, AB4 structure, and AB2 structure. So here are the structure of methane molecule that is formed by the carbon and 4 hydrogen atoms. So basically carbon has 4 uh, electron in the outer shell, so and have ability to form 4 hydrogen bond, or maybe 4 bond with another atom. So hydrogen have only 1 electron, so 4 hydrogen will be required to stabilize the carbon atom. So this pairing is by the sharing of single electron, and that will be in the form of covalent bonding, that is not ionic bonding. So this is the structure of methane molecule in the 3-dimensional structure, and we called it as pyramid, that are 4 hydrogens, and the angle between them is 109, and this is the space filling model, and that is the ball stick model of the methane molecule. Shape of molecules, basically these are the Vesper theories, and Vesper theories have different postulate to classify the different structure of the molecules. Shape is very important for each and every molecules because they are important in the reaction kinetics, and the structure of molecule is very necessary for the formation of bond. If an atom have, if assume as if this hydrogen is removed, and we will apply a sulfur atom or maybe a sodium atom at this place, then the structure of the atom will be changed, and if we apply another molecule at the same position on this side, then there will be the different reaction, and there will be the different result for the product. While if we place a different atom on this side that will have hydrogen atom at this side, then there will be the different product, and there will be a different reaction for this structure. So that's why the shape of molecules are very important for the chemical reactions. Later you will see the shape in the complex molecule like sugar, protein, nucleic acid, that determines the particular function in the cell structure. So there are polar and non-polar covalent bonds. Simply remember as if the bond is between the same type of an atom, that will be called as non-polar, and if the bond is between 2 different kind of atom, that will be called as non-polar covalent bond. So if a sharing between 2 atom is fairly equal, and the covalent bond is described as non-polar, and we can say that their dipole moment can be 0, because as the ability of hydrogen, that is called as electronegativity, the ability of electron an atom to extract electron from the other atoms. So both will have same type of electronegativity, then the molecule will have fair equal or fairly equal ability to gain electron. So that's why the bond length between them will be equal, so they will be called as non-polar molecules. So why methane is a non-polar molecule? Even they have different bond, as this side has carbon hydrogen, this side has carbon hydrogen, all the 4 side has carbon and hydrogen faces, while they are called as non-polar. The reason is that all the side that have a dipole moment of sum of 0, because hydrogen is a positive, partially positive charge, and the carbon will have partial negative charge, and the direction of dipole moment will be from hydrogen to carbon. So then this side and this side will cancel each other, because this hydrogen, the direction of dipole moment from hydrogen to carbon will be from left to right, while from this the direction of dipole moment from right to left. So both of these will be cancelled each other, and same for the upper and lower hydrogen. So that's why these molecule have zero dipole moment and can be called as non-polar molecules. So this is the simple structure, and now we will study the polar molecules. Polar, as we discuss in the action potential, the potential nerve impulse. So similarly, poles are only found when two kind of charges are formed. So if a sharing between two atoms is unequal, one is gaining more side of the electron while other is facing with the distance uh, for the sharing electron, then there will be the different cloud of the electron around the nucleus. So the sharing of electron between two atoms is unequal. The covalent bond is described as polar bond. So the polar covalent bond and non-polar covalent bond are basically the types of covalent bond, because they are both are formed by sharing of electron, not by losing or gaining of electron. Such as an example of H2O is called as polar covalent bond, because oxygen is more electronegative atom, while the hydrogen is have low electronegativity. So hydrogen will uh, put electron more toward the oxygen, while oxygen have more electronegativity, and the electron that is shared paired by between these will have more side toward the oxygen. So the size of this cloud will be shorter than the original one. That's why, that is the reason the structure of H2O is like as in the V-shaped. And so next is hydrogen bonding. Hydrogen bond is not actually a bond. Basically, it is a type of force that is more stronger than any bond. A hydrogen bond occurs between a slightly positive hydrogen atoms of the one molecule and the slightly negative atom of the another molecule, or between the atom of the same molecule. Hydrogen bond only form between the highly electronegative negative atom and highly highly low, sorry, highly negative electronegative atoms and the low positive uh, hydrogen atoms. So the presence of hydrogen is necessary for the hydrogen bonding, while for the negative atom, that can be in a variety form such as nitrogen, and it can be as oxygen, or it may be a family of other elements, while it can be fluorine that have more electronegativity, and that form highly electronegative uh, uh, repulsion of the electrons. So hydrogen bond only form between the slightly positive charge hydrogen atom and the slightly negative atom of the another molecules. And here we can see here this oxygen, the bond that is in the black form are not a hydrogen bond. This is the covalent bond between hydrogen and oxygen, while this hydrogen has partial positive charge due to this highly electronegative oxygen atom. So this oxygen atom from far space will attract the electron of the hydrogen, and that will be uh, shared as away from the hydrogen. So a simple interaction will be formed between this oxygen atom and this hydrogen atom, that will be called as hydrogen bond. This is actually not a bond because that is represented in the form of dotted line, not in the a complete line. So a complete line will be a complete bond, while the dotted line is called as hydrogen force or hydrogen bonding. And hydrogen bond is 20% of the an original covalent bond. Hydrogen bonds are very important in the final activities, shape structure of the key biomolecule like proteins. Hydrogen bond in water also, hydrogen bond is formed in water in the or in the other earth molecules. This is the structure of water molecule, and hydrogen bond is shared between this oxygen atom and this hydrogen atom. So this is the hydrogen bonding. Properties of water. Water has high heat capacity, and that's why they have heat of vaporization. And heat of vaporization is that an amount of heat that is required to vaporize a water molecule or amount of water 1 gram on the 1 Celsius. So it takes only 0.5 calories to rise the temperature of most other covalently bonded liquid by the 1 Celsius. So these are the some properties of water molecules. Water has high heat of vaporization as well as a good coolant, as it evaporates of our skin. Evaporization on our skin and have more ability to accept the or absorb heat. That is why this is called as excellent coolant. So properties of water. Water is a solvent, and it is also called a universal solvent. This universal solvent, it dissolves most of the substance in it, because it has hydrogen bonding and attraction of partial positive and negative charges. That's why it is a universal solvent. Most of the cell uh, reactions are formed in the water. That is because the properties of water. And all enzymatic reaction that are happens in our body always occur in the water medium. So water molecules are cohesive and adhesive. Cohesive forces are present between two different molecules, while the adhesive forces are present between the uh, same types of molecules. Water molecules declining toward because of the hydrogen bonding cohesion. Water positive and negative poles allow it to adhere to the polar substance. That is another theory of uh, transfer of molecules in the uh, seed structure or in the root structure. We will study in the biology. And these are the different properties of the water molecule. So that allow insect and to walk on the surface of the pond. Properties of water. It is a frozen water in the less dense liquid. Basically, the ice that in the frozen state have less density than the this water molecule. That's why the ice float on the water. So that is another property of water molecule. Fish in the mountain lakes appreciate that, and we will study in the chemical bonding. And what are acid and bases? Certain chemicals that are dissolved in the water are called as acid or bases. So the solution of water and these material are called as acidic, basic, and neutral. Neutral solutions are formed when they contain the properties of both acid and base, while the acidics are called as if they have uh, more hydrogen ion, and if they have more hydroxyl ion, they will be called as basic or alkaline solutions. So that is a complete chapter of acid and bases in chapter, that is chapter 8, that is called as uh, chemical dynamics. And this is a simple reaction of acid and bases. Water that is losing a hydrogen act as an acid, because there are different theories about the acid and bases. If they losing a hydrogen atom, that will be called as acid, and if they are accepting hydrogen ion, that will be called as a base. So acids are the substances that dissolve in water and release hydrogen ion. Simply, HCl is an example of acid, and basic solution that have low hydrogen ion concentrations, and similarly, they basic solutions are have more concentration of hydroxyl ions. Uh, so these acid and bases can be measured by their pH scale, and pH scale range from 0 to 14, and that is maybe from maybe by the uh, imbalancement of the hydrogen or hydroxyl ion. So these are the pH scale range from 0 to 14 may be by the embellishment of hydrogen and hydroxyl ion. If they have if they have equal amount, that will be called as neutral, and if they have high concentration of hydroxyl ion, that will be called as basic or alkaline, that is more than 7, and if they have more hydrogen ion concentration, that will be called as acidic solutions. So different substances that we use in our houses are maybe acidic or basic. Orange is acidic because it contain citric acid, uh, and different apple contain citric acid as well, while the lemon also is an acidic. So we will study a complete chapter on the acid and bases in chapter of chemical dynamics. And buffer, a buffer is a solution that have ability and that cannot that not allow any solution to change in its pH, that keep the pH in at the normal limits, such as our blood. And as we keep our temperature, body temperature, between a limited uh, ranges from 36 to 37, same as buffer act, and it will keep the pH in the normal limited. So that's why they are called as buffer, and our blood is a main constituent of buffer in our body, and this process is called as homeostasis. Buffer can be formed by different elements or different compounds that we will study in the next chapter. So organic molecules are those molecules that contain hydrogen and oxygen, and that is the simple definition of organic molecule. That is simple structure, and many molecules of life are made up of organic molecules, and it may be hemoglobin, carbohydrates, lipids molecules, etc. These all are organic molecules, and there are uh, uh, different method to prepare them, as a sponification method, uh, and they are in the form of polymer or monomers. So monomers are monosaccharides, amino acid or nucleotide, while the polymers are carbohydrate, protein, and nucleic acids. Different cells, the cell basically are formed by these molecules, such as carbohydrates, proteins, and lipids, and the nerve conducting ability that is maybe by the conductivity of lipids molecules, So that's are the by the charge on them. So there are different monomers that can be immersed, and they will form another molecule by combining. And there are different process of that can be used to reverse the reaction, that is called as hydrolysis of the major products. If we are using a water molecule, then they will hydrolyze the molecule into monomers. And if we are condensing the small molecules, that will be called as a condensation reaction. So basically these all are the about the basic chemistry, while we have to study a major chapters in the detail in these chapters that we have studied here, and this is the basic brief on these chapter that we have to study in the A level or O level books that we will study in the next classes. So if you have any question, you can ask me freely.
Guys, is everything is clear?
Yes, teacher, it is clear everything.
Okay,
Okay.
thank you.
Okay, guys. Okay. The class is over. Just try to connect to the next class today 3 p.m. Okay. So I
Okay.
want to see the next class. Okay. Thank you so much, Elias. Excellent class. Enjoy the rest of the day and have a wonderful day to all of you. Bye-bye.
Okay, thank you. Bye.
Bye, teacher.
Bye.
Bye. Samuel.